Good morning students. So the last video we have seen about the data types concept. So you know the 5 built-in fundamental data types. So what are all the 5 built-in fundamental data types? Integer, int, character, float, double, and another one is void. Okay, so you know how to declare as a data type and for what purpose, for which data type should be used, you know. So now we will see the memory representation of fundamental data types. So today memory representation of fundamental, that is how much memory space is allocated for each and every data type, that only we are going to see. Okay, as per stored program concept, every data should be accommodated in the main memory before they are processed. So C++ compiler allocates specific memory space for each and every data handled, okay, according to the compiler standard. So as I said earlier in the last video, compiler, for you have to denote the compiler, so which type of data is it. So similarly, when we denote which type of data we are going to use, it will allocate that much main memory space, okay. So see here the table, the data type, character, int, float and double. So in terms of bytes, in terms of bits. So you know 1 byte is equal to 8 bits. So for character, it can have only 1 byte. So how much space in memory is allocated? For character, it is 1 byte, int 2 bytes, float 4 bytes, double 8 bytes. So here they have given in bit value. So 1 byte equal to 8 bit, 2 byte is equal to 16 and 4 byte equal to 32 and 8 byte means 64 bits. So here they have given the range of value also. So for character means 1 byte means minus 128 to 127. Okay, so character values it can access, and similarly integer means minus 32,768 to 32,067. So from this value to this value. And then float. So see here, float you know very well, we are using it for decimal point. Here they have given the values here also in decimal point, that is 3.4 into 10 power minus 30, that is minus 0.0 like that, to 3.4 into 10 power 38 minus 1. Okay, so up to this value. Float double means you know it is also used for the same thing. So when I have the last video, when I had discussed about double itself, I was said it will have the double the memory space of float. See here it has 4 bytes, here it has 8 bytes. Similarly float also having the double the memory space of int. So float is having 4 bytes and integer is having 2 bytes. That is float has double the int and double has double the float value. Okay, so 64 bit and 1.7 to 10 power minus 308 and 21. So it is used for handling largest values. For that purpose we will be using this double. Okay, so this is the memory space allocated for the basic data types. Now we will see the data type modifiers. So what do you mean by modifiers? So modifiers are used to modify the storing capacity of the fundamental data type. That is, suppose if though you declared as integer, you may want to have only small value or you may want to have some large value. So for that purpose the modifiers help you. You may have positive value or you may have negative values for like that, okay. Except void type. So for except void type, for other 4 data types you will be having this modifiers, okay. So every fundamental data type has a fixed range of values to store data items. In data type, they can store only 2 bytes of data. In reality, some integer data may have more length and may need more space in memory. In this situation, we should modify the memory space to accommodate large integer values. So modify can be used to modify, that is expand or reduce the memory allocation of any fundamental data type. Suppose if you want to have small value, you can reduce the memory allocation. And if you want to have a large value, you can expand the memory space. So for that only we will be using this modifiers, okay. So there are 4 modifiers, that is signed, unsigned, long and short. So these 4 modifiers are used along with the data type, that is long int, then long float like that, short int, short float like that, so signed int. So these modifiers are used along with the data type. So that's why they are called data type modifiers, and except void, for other 4 data types these 4 modifiers can be used, okay. So see here they are given in the table. So that is for integer type. So first one is for integer type. So it's integer type. So short, unsigned short, signed short and int. So that is short is a short name for short int. So you know very well, so for int you will be having 2 bytes. So similarly also you are having the 2 byte space for short. So 2 bytes means you know 16 bits, the same range of value. So for int only you have the same range of value, no? So see here the int has the same range of value. Similarly you are having for short also. So unsigned short, so it also has 2 bytes 6, but the value is for only positive values. So 0 to 65,535. Okay, that is adding these two values, that is 0 to 32,768 plus 32, that is 65,535. That is the range. But though that is unsigned means it will not have negative values. So the values are only positive. So therefore the range is from 0 to 65,535. Okay, and then signed means it will have both negative part and positive part. So therefore 0 to minus 32,600 one part and 0 to 32,767 the positive part. So both the parts, so they have 2 bytes, that is 16 bits. Okay, and next both short and signed short. So here 16 bits only coming because 1 byte is equal to 8 bit only. So here 16 bits only. So next both short and signed short are similar. Okay, that is signed short also had both this, and if you short also had same thing. So you no need to give as the sign, you can simply give it as short itself. So next comes integer. So integer may or may not be signed. So the 2 bytes, so you know very well the integer memory space, how it is done. So next let us see unsigned int and signed int. So unsigned means the same thing. 2 bytes 16 to 65,535. Signed int. So signed int and int are same. Both short and int are similar. Okay. They have the same memory space, and they for signed int and int are same, short and signed short are same. And similarly for everything they will be having the same values. And next let us move on to the next data type, that is long. Okay. So you know very well we are using this is the access modifier, long. Okay. Till we have seen the access modifier, signed and unsigned and short. Okay. So now we are going to see long. Long is a short name for long int. Okay, so that is for long int, instead of long integer, that is for storing higher values, we will be using long. That is integer values only we are going to store. For what is the memory space? 4 bytes. That is double the value. So 4 bytes. Here we have only 2. So here we are having 4 bytes, that is 32 bits. Okay, so see the value minus 2147483648 to 21474836. So when you are going to have this number of digits, that is the largest numbers, you can use this long, access modifier long. So unsigned long, then it also has 4 bits, but it is from 0 to the double the value this side. When you add these two, that is the positive side. We will be having 4,294,96295. For signed long, it is similar to long and signed long. So the same value has been here. So everything has the 4 bytes as their memory space. Okay. So this long is modifier and int is a fundamental data type. So you know that. So next we are going to see the character. So for data type character means we will be having unsigned character and signed character. So character means, so we have only 1 byte. So first itself we have seen the character data type will be having only, how much memory space is allocated for that? Only 1 byte. So 1 byte is equal to 8 bits, you know, and the range of value is also very small, from 128 to 127. And similarly unsigned character, so 1 byte, that is 8 bit, that is also similarly 0 to, the negative part is also added to the positive means it will be having 0 to 255. So in the last video when I have given an example program, so I gave an example program for explaining the character and integer. In that also we have seen that, so 0 to 25, I will ask you to enter a value 0 to 255, isn't no? So you will be giving 101 value, the corresponding ASCII character for the number 100 is small d. Okay, that program only we have seen in the last video. So unsigned character means 0 to 255. So signed character means that the same 1 byte minus 128 to 127. So int long, now we have seen the character with unsigned character and signed character. So next we are moving to floating point type. Okay. So floating point type, you know very well, floating point type we are using for decimal values. So when we are going to use decimal values, numbers with decimal point, we will be using this float type. So float signed fractional value. So it has a memory 4 bytes and it has a memory 32 bits, and signed more precision fractional value, that is double. So you know very well double means it has double the space of float. So signed fractional value 4 bytes. So signed more precision fractional values means it will be having, what do you mean by precision? Precision means that after the decimal point, how much numbers you are having, that is the precision. So mostly we will be rounding off to 2 decimal points or 3 decimal points. Suppose we are having more, after decimal point, if you are having more values, suppose we are dividing a number, then it will be, suppose we are dividing a number 10 by 3, then what will be the value? If you are dividing a number 10 by 3, then what will be the value? It will be going on as 3.33333, that will be going on. So the precision value, fractional value, it has many values, isn't no? So for such values, you will be having double, and the memory space allocated for that is 8 bytes, that is 64 bits. Okay. So see the value 1.7 into 10 power minus 3082, 1.10. So already you know the float and double value that we have seen in the previous example. So next, long double. So signed more precision fractional value. So already double itself we are using for more precision. Long double means we are having largest value, then we will be using long double. So the memory space used for that is 10 bytes. Okay, 10 bytes, so 80 bits. The value is 3.4 into 10 power minus 4932, 1.1 into 10 power 4932 minus 1. Okay, so this is for the floating point. So memory allocation is subjected to vary based on the type of compiler that is being used. So what type of compiler you are used, according to that also sometimes the memory space allocated will be changing. Okay, will get changed. So let us see. So now we are using the software. What software we are using? We are using developer C++. But in the earlier days, that is some years ago, we used to have one compiler, that is Turbo C++. Okay. So when we learned C++, we used to have this platform Turbo C++ compiler only. So for you, the prescribed compiler is developer C++. So the Turbo C++ and developer C++, for most probably they are having the same thing, but sometimes the memory allocations will be varying. Okay. So see here that they have given a table, the memory allocation, how it differs from developer C++ and Turbo C++. Okay. So short, then turbo to developer also to, unsigned short, signed short, and for them they are having 2 bytes. But integer, see here, turbo has 2, but in developer C++ we are having 4. So unsigned int also 4, signed int also 4. So as a book is based on developer C++ compiler, they have given in your book as 4 bytes. Okay. So unsigned long, signed long, character, all others are same. The another one change is in long double. In long double, Turbo C++ have 10 bytes, whereas in developer C++ we have 12 bytes. Okay. So only for integer we are having more space in developer C++. For all other data types with modifier, we have the same memory space allocation only. Okay. So similarly, number suffixes in C++. There are different suffixes for integer and floating point numbers. So suffix can be used to assign the same value as a different type. What do you mean by suffix? Suffix means after a number, at the last what you are giving is suffix. So if you are giving before the number, then it is called prefix. So I think you know very well. So for example, if you want to store 45 in int long, unsigned int and unsigned long int, you can use the suffix letter L or U. That is either case means either you can use small l or you can use small u. That is 45L or 45U. 45L means it is long and it is unsigned. Okay. So similarly, you can use F for floating point values. That is 3.14F. Like this you can use. Okay. So next we will see the evaluation part of it. So these are the questions given in your book to evaluate. Okay. So what are modifiers and what is the use of modifiers? So you have seen the previous part you have seen what are the modifiers and what is the use of modifiers. So modifiers are used to modify the storing capacity of fundamental data type except void type. So as I said, except void data type. So there are 5 fundamental data types, except the void, other 4 you can modify them. That is, you can expand or reduce the memory allocation of any fundamental data type. So they are also called as qualifiers. So modifiers are also called as qualifiers. Okay. So what is wrong with the following C++ statement? Long float x. Long float x. So what is wrong? Can you think what is wrong with this? Is there any modifier like long float? No. You are having only long double. So long float is not a valid data modifier. We can give only as float x. Okay, we can give only float x. So long double only is available. Long float is not a built-in or a valid data modifier. So that one is the wrong in this statement. And what is the wrong with the next following statement? It is constant int x. C-O-N-S-T int x. Okay. So you know very well const is the keyword used for the storing a constant value. So here constant int x, but we have not specified any value for x. So as it is declared with const keyword, it must have a constant value for the variable x. What is the constant? That will never change throughout the program. Here no value is assigned to the variable x. Therefore compiler asks the user to assign a value to the variable x. Okay. So constant means that value will never change. But here we have not specified any value. So that one is the wrong in this statement. So next, the data type character is used to represent characters. Then why is it often termed as an integer type? Okay. So the data type character is used to represent characters. Then why is it often termed as integer type? So you know very well character data type is often said to be integer type since all the characters are represented in memory by their associated ASCII codes. Okay. So if a variable is declared as character, C++ allows storing either a character or an integer value. Okay. So it is associated with every ASCII value. So ASCII codes are with numerical integer value. So therefore it is often termed as an integer type. So character data type is also termed as an integer type. And next one, what is the advantage of floating point numbers over integers? Okay. So as I said earlier, floating point numbers will be occupying more memory spaces. No. So there are 2 advantages of using float data types. They can represent values between the integers and they can represent a much greater range of values. So the integer they can represent a much greater range of values. At the same time, they can represent values between the integers. So these are the 2 advantages of floating point numbers. Okay. And next one, the data type double is another floating point type. Why is it treated as distinct data type? Okay. So float ங்கிறது ஏற்கனவே decimal point தான் நம்ம வச்சிருக்கோம். Again ஏன் double னு ஒரு distinct னா தனியா ஏன் ஒரு data type னு ஒன்னு வைக்கணும். Data type double is another floating point type. Why is it distinct data type? The double is also used for handling floating point numbers only. But this type occupies double the space than float type, which means more fractions can be accommodated in double than in float type. The double is larger and slower than type float. Okay, it is larger as well as it is slower than the type float. So next, what is the use of void data type? So the literal meaning of void is empty. So here in C++, the void data type specifies an empty set of values. So it is used as a return type for function that do not return any value. So mainly still we have learned about how to use the main function. So sometimes in our program we will be having some subprograms, means if that function does not want to return any value, then we have to declare that function as void. Okay. So I think you are clear with this questions. That is the evaluation part given to you. So be clear which type of modifier is accessed with which type of fundamental data type and what is the syntax for everything in a C++ program. So today we have seen the modifiers, that is signed, unsigned, short, long, and to which data type they are associated with it, and what are all the memory space we have allocated by the compiler in memory. Okay, so for each data type and for each data type with modifiers, how many memory space are allotted in the system we have seen. So, and we have seen also the evaluation part. So students, I think you are very clear with this. This 9th chapter is a big chapter, but it is a very basic concept for your C++ program. So be thorough with this chapter. Okay, so there is in 9th chapter we are having part by part. So we have seen about the C in, C out statement, then a sample program, then we have come across data types, then variables, then these modifiers. Okay, still chapter 9 exists, still some part we are having. Okay, that we will see in the next video. So have a note of this students evaluation part. So these are all the questions they have. These are not your book bag questions. So this is not your book bag questions, mean that for every chapter they will ask the background. This is the evaluation process. Sometimes they may ask from this questions also. So have a note of it. So thank you students.